All right. I want to talk to you guys quickly today about how to find the x and y intercepts of a line. So typically we see lines in three different forms. There is slope-intercept form, which everyone probably knows as y equals mx plus b. That one is nice when trying to find x and y intercepts because the y-intercept is given to you. B is your y-intercept, but we'll talk more about that in a minute. There's standard form, which is actually my favorite of the three forms when finding x and y intercepts, and that is ax plus by equals c. And last but not least, we have my favorite linear equation of all when you're in calculus, and that is point-slope form. All right, so the first example I want to do is with slope-intercept form, so I have a nice equation right here for us. Y equals 2/3 x plus 7. So, when we talk about x and y intercepts, we're talking about this line, right? So if I were to graph this line, it would look something like this. That's not perfect, but it would look something like this. All right. And I know it's going through the point 0, 7, which is the y-intercept. So that's why we like slope-intercept form, because the y-intercept is given to us. And I'll explain why in just a minute. But I really kind of want to just talk about what x and y intercepts are. So your y-intercept is the point on the line where the line crosses the y-axis. The x-intercept is the point on the line where the line crosses the x-axis. And what's cool about those intercepts is that they both have something in common. No matter what point I have on the y-axis, the x-coordinate of that point will always be 0. Right? Isn't this like 0, -1? This would be 0, -2. So if I ever have a point on the y-axis, I do know that the x value of that point is 0. Likewise, if I ever have, let me just erase this a little bit. And let's get that axis back on there. If I ever have, here we go. If I ever have an x-intercept or any point on the x-axis for that matter, the y value of that coordinate is always going to be 0. So I don't know that x value yet, but I do know that the y value of that point is 0. Any point on the x-axis has a y value of 0. So again, those are some really important things that are going to come up in just a second. I just want to get rid of these points because I'm just talking about this graph for a second. All right. So we have a y-axis and x-axis, and every single line for the most part, aside from some special ones, will have x and y intercepts. So let's get back to slope-intercept form. So slope-intercept form is lovely because the y-intercept is given to you. So I can just put that here. I always like to make charts. So my y-intercept and my x-intercept. So we know that the y-intercept is when x is equal to 0, okay? So sub in 0 for x. And when I do that, I get y equals 2/3 times 0 plus 7. All right, so anything times 0 is 0, I get y equals 7. So you can very clearly see that the y-intercept is 7 because the x value is 0. So we're going to do the opposite to find the x-intercept. I know I need an x value, so I'm going to sub in 0 for y. So let's see, that's going to be 0 equals 2/3 x plus 7. I will subtract 7 from both sides. I am now going to choose to multiply both sides by 3. On this side, on the right side, your 3's are going to cancel out, and you're going to be left with 2x equals -21. Divide both sides by 2, we get our x-intercept is -21 over 2, -10.5. I typically keep things in improper fractions. But again, you always want to write those intercepts in ordered pairs because they are points. So I can fill that in over here, 21 over 2, -21 over 2. Make sure we can see that negative sign. But yeah, that's in short for every single form. That's going to be the way that we find x and y intercepts. What's nice about slope-intercept form is that one of them is given to you in the equation. But if you remember from before, I kind of told you that's actually not my favorite. My favorite for finding x and y intercepts is standard form. Because if you look back over here, we had to do a lot of algebra to solve for x over here. It's moving to the other side, multiplying by the denominator, and that can get pretty ugly and pretty tricky sometimes. So in standard form, it's lovely. So let's just say we have 5x minus 8y equals 24. What's nice is when I go to make that little t-chart, there's not any real crazy algebra just based upon the way it's set up. So to find the x-intercept, I want to sub in 0 for y, right? Because that's going to be the point that's on the x-axis. So the y value, no matter where it is always going to be 0. So watch the magic that happens here. When I sub in 0 for y, that whole term disappears. Okay, so I'm going to have 5x equals 24. And I get x equals 24 over 5, which we could do as 4 4/5. If you kind of wanted to see where exactly it was on the coordinate plane, you could write that as 4.8. Again, I'm typically a fan of the improper fraction. And then over here for the y-intercept, again, it's not going to be any crazy algebra when we're solving for the y-intercept. We're going to sub in 0 for x. Okay, and I get 5 times 0. And look at this. This isn't even a fraction here. This is nice. So I get y equals -3. So my y-intercept is 0, -3. So again, it's the same exact process, just the format that the equation was given to you in is different. So I typically, I like to find x and y intercepts when I'm in standard form because I find that the algebra to get to my answer really isn't that bad. But again, it's just remembering about what intercepts are. If it's an x-intercept, the y value is 0. If it's a y-intercept, the x value is 0. Think about where you would be plotting that point on this coordinate plane here. And last but not least, we have, oh, look at this. I already have the t-chart set up for us. We have point slope form. So let's just refresh our memories as to what point slope form is. Okay, and I'll give us an example. We'll do y minus 10 equals 4/5 times x minus 8. All right, so 4/5, m is always our slope. And then the point on the line here that was given to us was the x1, y1. So I do know that 8, 10 is a point on the line. However, that's not an intercept, right? Because the x value is 8, the y value is 10. In order for something to be an intercept, one of those would have to be 0. So let's go ahead and do the same exact process. And you'll see one of them, again, we have to do a little bit more work, and the other one's going to work out pretty nicely. So let's find the x-intercept first. So I want to plug in 0 for y. So that would be 0 minus 10 equals 4 over 5 times x minus 8. So this is going to be the ugly one. All right, so I have -10 equals 4 over 5 times x minus 8. So people have different methods. When I have a fraction in an equation and I'm trying to solve, the first thing I do is I multiply both sides of that equation by the least common denominator of all the fractions. So here the fraction, there's just one fraction, so the denominator is 5. So what's nice here is that these 5s cancel, and I'm going to be left with something like -50 equals 4 times the quantity x minus 8. All right, so let's see, now it's going to be nice and easy to solve. So -50 equals 4x minus 32. We can add 32 to both sides. And I'm going to be at -18 equals 4x. And I have found my x-intercept. I'm going to simplify that to -9 over 2. All right. And then this one's going to be the nicer one. Okay, and we'll see why in a minute. So if I plug in 0 for x here, I'm left with y minus 10. And this is going to be real nice here. So let's just simplify that. So this is going to be 4/5 times -8. And we have fractions, but again, it's nothing. Fractions aren't scary. So it's going to be -32 over 5 equals y minus 10. So I'm going to add 10 to both sides. But over here, I'm going to write it as 50 over 5. So I have a common denominator. So y equals 18 over 5 as my y-intercept. So that's 0, 18 over 5. Again, super easy. But you can see why standard form was my favorite, because really it was just a term disappeared and you just had to divide to get your answers. And again, don't be afraid of fractions. Fractions are numbers too. That's basically it. So I hope this helped you find x and y intercepts of a line if you needed some help with that. Have a great day.